This video is an attempt to show that the GARMIN eTrex 10 can be used as a third order survey device. I have mounted on a tripod using some hardware and some aftermarket mountings to attach the GARMIN onto a standard heavy-duty video tripod. Now I have, before I got out here, run this X marks one spot, and I have run a first order GPS survey unit over this point and another point down there 300 some feet away, the calculations of which I will show in just a minute. I'm going to turn on the eTrex, and the button is just right over here on the side. The satellite imagery will come up. I use the toggle switch to run down to satellite. Calculator, sun and moon, calendar, waypoint averaging, proximity alarm, satellite. And I push the button to enter that mode, and it shows the satellites as they come up. Now I'm using both sets of Russian and US satellites. I have shot this before, so we're going to go back and we're going to go to waypoint averaging. It's not working. Let's go back here. Back to satellite. And we got into calendar here somehow. There we go. Now, when you measure an average shot, it will come up and it'll show you the progress and show you when it's 100% finished. So this satellite image and shot will be recorded in the GARMIN. Here we are at the second point. The second point is a brass nubbin marked CERPCL, set by the city of Eugene as a control monument. It also has been shot with first order GPS, and the GARMIN is now set up, and the bubble is in the center, the frog's eye bubble is in the center, and it is over the point. Okay, recorded in the notebook is the shot on the X and the brass nubbin 300 feet away. The first shot was 92 minutes closure, and it didn't check too good, but it checked way more accurate than the stated accuracy of the machine. This is the check shot that I used to do the calculations. It is a little bit different than the check shot that I just showed you in the field book. This is the fourth recorded check shot over the two known points, and I will record my calculations in the next segment. Alright, the circumference of the Earth at the equator is 40,075,160 meters. But if you measure the Earth through the poles, the circumference is a bit shorter, 40,008,002 meters, which is just a little wider than it is tall, giving the Earth a slight bulge at the equator. This shape is known as an ellipsoid, or more properly geoid, Earth-like, from Wikipedia. Other sources use the figure 40007 kilometers for the Earth's pole-to-pole circumference. We will use the figure 40043,093.323 meters because the data was collected at the 44th parallel. This is from Universe Today. Data sheet was used to convert the latitude and longitude measurements from degrees, minutes, and seconds to a decimal location at the 44th north parallel, which we are here in Eugene, Oregon. The spreadsheet will be used to convert the degrees to meters. And if you figure the 44 degrees, the Earth is 360 degrees at 44 degrees. Therefore, the number of the radius of the Earth, or the circumference of the Earth at the 44th parallel, 400,43093.23 meters divided by 360 will give us 111,230.8145 meters per degree. Adjusting for the elevation, the instantaneous circumference of the Earth at Eugene, Oregon is 400,430.93 meters. Multiplying this and reducing the number creates the coordinates in state plane, not state plane, but in trigonometric and geometric terms. Pythagoras was used, the Pythagorean theorem was used, and the latitude and longitude between the 2 points was checked and read to the nearest 1,000th of a minute. This should produce a difference of 1.8538 meters, which is the standard given to the stated accuracy of the GARMIN eTrex 10. This goes on with the field data and produces a number difference of 67 hundredths. The difference between the first order work and the eTrex 10 was 67 hundredths at 300 feet. That's well within the bounds of a third order survey. And if the distance was punched out farther, say 2 miles, that 67 hundredths of a foot becomes almost unmeasurable with modern techniques. So I would say the accuracy of the GARMIN eTrex 10 used up against standard survey equipment and techniques is plenty accurate enough to produce mapping techniques, topographic mapping techniques, and benchmark checks for standard surveying. Thank you for watching my YouTube video, and we'll catch you with the next video. Thank you very much for watching.